Okay, question 1. There's 3 acids here. Use the information to determine the strongest one. So the strongest one is going to be the one that dissociates the best. And so Ka is products over reactants. So high Ka means is high products. Therefore, highest Ka is most associated. And strongest acid. So H3PO4 with Ka 7.1 by 10 to the minus 3 is the best. Okay, so that means H3PO4 and the conjugate base would be this one, H2PO4 minus. Okay, I'll just check the mark scheme here. Largest Ka. I didn't say identify S as a proton donor and the proton acceptor. Use information in terms strongest and explain your reasoning. Okay, so I only get 2 out of 3 because I was explaining why it's the strongest acid, but I didn't define Bronsted-Lowry, which is not necessarily explicit in that question. Yeah, I think the third part is definitely God mode there. That's a bit dodgy. I don't really need to... I've fully explained why it's a stronger acid. Oh well. That's what God mode's about, okay? For some reason, you need to think that I need to also explain what a Bronsted-Lowry acid is. Even though they're all Bronsted-Lowry acids and bases. Okay. That's a nasty one. Okay, I'd be interesting to see how many people, I'd like to see the stats, actually did that. But anyway, so let's moving on. Identify an amphiprotic species from the dissociation reactions. Okay, so the ones that can give and take both protons. So this one here can gain to H3 and then go to H, and so can this one. This one can go to H2 and then can go to H3. So H2PO4 minus. So HPO4 2 minus and H2PO4 minus can both gain or lose protons. Therefore, both amphiprotic. All right. I'm checking mark schemes as I go here because they're all a bit dodgy and I'll forget. So the mark scheme says this one's amphiprotic. There's actually 2, so I think they've missed one because it can donate or accept a proton and therefore act as a Bronsted-Lowry acid base. Identifies the species. Okay, thank God I didn't have to repeat the word Bronsted-Lowry. That would be really dodgy. But I got both those points. The mark scheme's missed one, unsurprisingly. All right, so moving on. Determine Kb for the strongest conjugate base formed when... So when they say that's fully dissociated, I'm going to have to assume that that is fully dissociated. So that's to PO4 3 minus. All right. Not super confident, right? So I'm going to go for that being fully dissociated, and so that's then going to go to HPO4 2 minus plus OH minus. So it's going to do that. And so I've got my Ka for that as 4.5 by 10 to the minus 13. That's a little tricky. You know, you can probably appreciate by now I don't trust the writers that they've asked for the right thing, but I'm going, that seems to be the best thing. Certainly some confusion there. Now if I go to I'm never quite sure if there could be a mistake or a misunderstanding. So I'm going to go for this KW equals Ka times Kb. Now unfortunately it doesn't tell you what Kw is, so Kw is always 10 to the minus 14. So let's just rearrange that. Kw over Ka, 10 to the minus 14 over 4.5 by 10 to the minus 13. So I'll just plug that into the calculator. Okay, so that it's a calculator there, so that gives us 0.0222 sig figs. So we're just going to go for 1, 2. So 2.2 by 10 to the minus 2. All right, so I'm just checking the mark scheme. That looks okay. Okay, last one for this question. Calculate the pH of this concentration of that. Show your working and state any assumptions. So for this one here, it's this substance here. So I think I should write that out, that equation, so I know what's going on. Always write out your equations. Now this is a Ka, so I don't need the H2O. So there's HPO4, 2 minus, plus H plus, and the Ka for that is 6.5 by 10 to the minus 8. Okay, so it's just easier to do a rice so you know what's going on here. So that's the reaction is 1 is to 1 is to 1. You've got 0.05. You're going to lose a certain amount, and so that's 0.05 minus x. And you've got x and x. Okay, so first of all, as Ka is very small, this equals 0.05. Concentration of H3PO42 minus is equal to concentration of H plus. All right, so stated my assumptions. So just write the expression out. So Ka is products over reactants. You can check this in the data booklet too. So what do we got? 6.5 by 10 to the minus 8 equals x squared over 0.05. So x equals the square root of 6.5 by 10 to the minus 8 times 0.05. All right, just pause while I do that on my calculator. Okay, so we got that there. So that's 5.7 by 10 to the minus 5. All right, so we need to work at, so that's the hydrogen ion concentration. So the pH equals negative log hydrogen ion concentration. So that equals negative log of 5.7 by 10 to the minus 5. And just type that in. And the answer there is 4.2. Okay, question 2. Polypropylene is a polymer. That PET is a polymer of carboxylic acid and ethanol. There's PET here. Find the monomers. So the carboxylic acid and the alcohols are obviously here. So that must have been in the OH there in the H there. So draw the structural formulas for the carboxylic acid monomer. So I'll just mimic the one that's drawn above. Even these things which aren't accurate, that's okay. So there's that there, and then there's just a repeat over here. Okay, so that should be fine. And then just doing the same thing over here. Must be the alcohol over here. So just mimicking the one above exactly. And then there must be an alcohol there, so that should be fine. Just checking. Correct structural formula. Why are they giving the name there? Okay. So you didn't have to name it, but it looks like the picture, so that's all good. Okay, I'm mimicking it. Normally I would draw out the bonds. It's better too, but because there's a picture there, it's best to mimic it rather than draw it more accurately with showing the bonds. All right. Okay, determine the type of polymerization used to form PET. Well, I've done that already. So the H2O comes out. So H2O comes out. So it is a condensation reaction. All right, identify the functional group formed by the monos. Okay, so you know when you've got an alcohol carboxylic acid, you memorized your reaction, so you know that's an ester. So this is actually quite an easy question. Determine the type of polymerization used to form polypropylene. Well, polypropylene, determine, that's an interesting word. I don't think you're determining anything, it's just addition. It's an alkene. So how about what? These cog verbs are a bit dodgy, a bit artificial. So that's just going to be addition, that breaks up. All right. Don't know whether there was any determining in there, but that's okay. Explain how the position of the methyl group of the polymer chain affects the strength of the methyl. I have to assume it's for this polypropylene. So isotactic. Oh, it is polypropylene. So you're going to have like your chains here, and you're going to have this thing pop up. So every two, there's going to be like your methyl group. So iso is all on the same side. And syntactic will be just alternating. 5 marks, it's a bit scary. Don't see how it's going to be worth 5 marks. It's a bit dangerous. So I've labelled it, that's helped, or drawn a picture, that's going to help. So for isotactic, the methyl groups are all on the same side. This will allow the chains to compact together. Being closer together allows for stronger London dispersion forces and so a stronger material. Just say the opposite for this one. For syntactic, the methyl groups are what is it? On either side in a pattern, even pattern, which has more spaces, so less compact, further away from each other. So weaker London dispersion forces. And a weaker material. Alright, I don't know what else we can say. I'm just going to go straight to the mark scheme. 5 marks is a little bit annoying that it's that many marks for that. Let's see how we go. Regular range identifies regular arrangement metal groups. Well, kind of, yeah. Identifies metal groups opposite charge for syntactic and the same time iso, yeah. Indicates isotechnics compact, yes. Increased intermolecular. Oh, they didn't even ask for London dispersion. That's a bit shady. All right. Indicates industry strength. Yeah, I got them all. Actually did a better job than the mark scheme, surprisingly, or not surprisingly. Okay, a big organic chemistry question. Now going by consistent subject reports in Queensland and other states, it doesn't matter how easy we make these, everyone gets them wrong. So people just aren't doing their memorization work at the start. Already I can see bromine, alcohols, and esters. Like that's the only thing they're missing is addition, which we've already done already. They're the main ones. So it should be pretty easy. So identify compound D. So what do we got? We've got butene, butanol, propanol. We need to draw those out because oxidation alcohols won't occur in tertiary, and secondary only goes to ketone. One propanol, that's definitely primary. This one's secondary. They're straightforward. All right, so compound D, if it's decolorized, it must be due to a double bond. Okay, so which one has a double? So D is 1-butene because bromine reacts with double bonds. To decolorize. All right, very straightforward. It's just memorization. All right, write a balanced equation to try to decolorize bromine. They've just I've almost given it away. UPAC names for the product formed. Oh, this one's a little nicer because it's got Markovnikov's rule. So it's worth actually drawing the full structure out here so don't screw that up. So the carbon with the most hydrogens will be this one. So this will be interesting. Oh no, sorry, it's not Markovnikov's because it's both bromine, so you don't have to worry about that. Balanced equation. Okay. So there'll be a bromine here and a bromine here off the double bond. And then you just draw the hydrogens in there. All right, so it's not anywhere near as hard as it could be. They could have added HBr in this one. All right, so that is 1, 2 dibromo butane. All right, if you're finding that tricky, you definitely haven't done your memorization or your basic work there. These are just the standard. They're quite repetitious. I think once you've done quite a few exams, you should find that they're just doing the same thing over and over. But people are still getting them wrong over and over. So there you go. All right, compound C. So C, so we've knocked out D over here. So this one's D. All right, so these are the alcohols. So they're A and B. So this one must be here. This one must be C. and that's the only help we get for that. So the reason we know that's because we know the other two are alcohols. So 3 marks is a little scary. I'd reuse this. Always use every piece of information, even if it's redundant. You still restate it. That's a bit of God mode there. And state the obvious is God mode. And then try and work out if the writer's made a mistake in the answer or the question is also God mode. I don't know how I'm going to get 3 marks for this. As easy as it is, the trick is getting the 3 marks they want you to get. So I'll just start off with the C is butane. Because alkanes don't react with bromine unless UV. And in test 1. In test 2, A and B both react, so they must be the alcohols, which is 2-butanol and 1-propanol. Leaving just butane. Butane does not react. Stating the obvious, because I've kind of just said it already. With KMNO4. What else can I say? Test 3, there's no A, B, and C in that. All right, so how do we go? Let's just go to the mark scheme. Identifies compound C as butane, got that. Cannot be oxidized. Oh, there you go. Do I have to say it can't be oxidized? I did say I didn't react with that. I don't know if they'll give that to me. Concludes that compound C is unreactive and saturated. Am I doing the right question here? It is reactive if you use unreactive. That's a in what situation? That's a really weird. That's a dangerous word to use vaguely like that. I've already said it is reactive if you've put UV in there. So unreactive in what situation? It can't be oxidized by possibility. I didn't say the word oxidized. Now I don't see the need for saying that. It's not wrong. And undergo addition reaction with bromine water, therefore compound C is unreactive because it's saturated. That's a silly thing to say because it's saturated, because it does actually react even if it is saturated. So I'm going to give myself 3 for that. They have asked for you to describe the type of reaction in 1 and 2. So addition and, well, I didn't say addition, but they did say oxidation, which is not in the question, that you have to identify the type of reaction. And again, I think that is, the answer there highlights the fact that their mark scheme is not that great because I've added a further insight into that. So I think for that reason alone, they should give me 3 because I think it is a better answer than theirs. Even though describing their actions is more detail. Try and do that too if you can remember it. All right, I'm going to move on to D. Draw the structural formula of compound Y. Okay, so we've got ethanol, concentrated sulfuric acid, gently refluxed. So what we're doing, fruity smell produced, compound Z formed. Compound Y, no apparent reaction. So what is compound X? Oh, here we go. Sorry. Compound Y. All right. No reaction, so that must be the ketone. Draw the structural formula of compound Y. So that's the secondary that goes to a ketone. And this will go to a carboxylic acid. And that's why it forms the ester. Okay, so we just got to do the ketone for B, which is the secondary. So compound Y, it's decolorized to ketone, so I think we need to draw. I think I'll just put it in brackets because there's no place for it. So the alcohol's here. And then it's been oxidized to a ketone. So I can just draw it out here. So I'll just draw the ketone in there. And we're done. Okay, so if that's correct, yeah, 3D is correct. Okay. I advise you not taking that much room. I wouldn't go to another page. Marker might overlook it or something. All right, don't take that risk. Identify compound B. Just identify it. Have I worked out what B is already? Shouldn't you have done that earlier? That really is mucked up. Okay, so I already had to do that already. Identify it. So 2-butanol. Doesn't make any sense that they ask. You would have had to have thought that through already to get this question. Draw the structural formula of compound Z. Where is Z? Okay, Z's an ester. Again, you have to do several things here. So they're asking it in the wrong order. So that's 1-propanol. Is A, and then A goes to X, and then X reacts with ethanol. So again, you really need a little bit of help here. And that's a propanol, that's then gone to a carboxylic acid, and then you've grabbed the ethanol, and then this has been removed. So you're going to have this going on, and that's the stem. Just put it in brackets so they don't count that as an answer. And I've got this here. So then that's the stem. So it's propanoate. And that'll be the little bit on the end. So it's ethyl propanoate. All right. And that's all good. Question 4. So we've got this many moles hydrogen gas. We've got iodine at this temperature. Got an equilibrium of this. Okay, so starting off, the equilibrium law expression. So that's products over reactants. So HI squared over H2 times I2. Oops. Okay, so that is standard. It just looks like a standard question. So I always do the rice, so we know exactly what's going on here. Well, there's equilibrium, but just don't get confused about anything. So the reaction quotient, the reaction stoichiometry is 1 to 2. We have initially, it's 1 liter, thank God for that. So the concentration is just that. So 5 times 10 to the negative 4. The iodine is just 1 times 10 to the negative 3. This is nothing. But at equilibrium, it's 9.3 by 10 to the minus 4. So this is increased by 9.3 by 10 to the minus 4. So these two are going to be equal. And the change is going to be this one here is going, if it's gone to 9.3, that means this one, by the stoichiometry of the reaction, it's half of this. So it's not X at all. We can work this one out. So it's it's minus half of that. So minus 9.3 by 10 to the minus 2, minus 4 on 2, minus 9.3 by 10 to the minus 4 on 2. So the change is, so do a negative and a negative there. So I'm going to have to give myself some more room here. 5 by 10 to the minus 4, minus 9.3 by 10 to the minus 4 on 2. And just pause here, and I'm just going to do the calculations for this one too. And I'm going to do the equals one for this one as well. All right. Okay, so that one, you can see the calculator there. That's 3.5 by 10 to the minus 5. And this one here, I'll just write that one out. Minus 9.3 by 10 to the minus 4 on 2. So just pause again while I type that in. Okay, and so if you type that in, you can see I've got 5.35 by 10 to the minus 4. So I'll just type that in. Sorry, that was a minus, right? Minus 4. Double check these calculations because they're a bit complicated. All right, so where am I? So to the KC, I'm just going to draw a line there just to save. There's my formula there. So it's 9.3 by 10 to the minus 4 equals 9.3. Where's my KC? Do I have a KC? Calculate the KC. No, I don't have a KC. All right, 9.3 by 10 to the minus 4 squared divided by 3.5 by 10 to the minus 5 times 5.35 by 10 to the minus 4. Okay, just pause again, and I'm going to type all that in and see how we go. All right. Okay, so typing these things into the computer, it's more a test of whether you can type the numbers in correctly. So I would probably do this bit first and then this bit, and then do all your double checking. I get a good half an hour at the end of all of these exams to go over everything. So 46.2. In case you make a mistake, which is very easy to do. Okay, predict the effect that adding a catalyst would have on the reaction rates, position, the equilibrium, and K value. Okay, so make sure I say all three. That should do us. Catalysts will increase both the forward and reverse reactions. Equally. So the position of equilibrium will not change, and so the value of Kc will also not change. All right, almost down to the end of the test. This has all been rather easy besides just doing a little bit of God mode here and there. Marks again, catalyst, so identifies catalyst speeds both forward. Yeah, of course. Identifies no effect on the equilibrium or the Kc. Too easy. Okay, last question, question 5. Looks pretty nasty. Let's see how we go here. So what are we doing? We're getting iron and reacting it with acid and then titrating it. All the ions converted to Fe2+, reacting with acid, watching gas. Solution's made up of 500 mils. So whatever that reacted is in 500 mils. You take 25 mils of that and reacted it with this. So there's the titration bit. So balanced chemical equation through reaction between iron ore and the sulfuric acid. So that's this bit here, giving a hydrogen gas, so metal plus acid gives gas, of course. So iron solid plus H2SO4 aqueous, got goes to hydrogen gas plus the salt, so iron sulfate. It's 2 plus, so there's FeSO4, and that will be aqueous. All right, so that should be fine. All right, should all be 1:1 then. So identify the species oxidized in the reaction in 5A, explain your reasoning. So it's always best to go for oxidation numbers. It's the easiest thing to do. That overall is 2 minus, that's 2 plus. Iron increases in oxidation number from 0 to +2, should be +2, therefore is oxidized. All right, mark scheme says identifies that iron is oxidized. Yeah, indicates Fe loses electrons to form Fe2 plus. Yeah, that's one definition. They're going to have to accept any definition, you know. It's gained oxygen is another definition. Oxidation number is always the best, and they don't have that. There's no way they could reject that, as it is the best way to do it. Okay, this one. Apply your understanding half reactions to balance the redox reaction. So there's no spacing in there. It's 2 marks. Are they expecting us to guess? Ouch. There's time for it, and I'm not going to guess. So this is going to take a long time, and it's worth nothing. All right, so I'm just going to do it down here on the next page. This is going to take a while. So, sorry, I'll just do this as fast as I can. You'll see how fast I can do it, I guess. We don't really know this and this yet, so I'll ignore those. This is the one that's getting oxidized. That one will be getting reduced. We'll do the oxidized getting first. We're done with that. I've gone through all the steps. There's not many steps to do than that one. Same there. Add some oxygens there. Add some hydrogens there. That's a total of 2 plus on this side. That's a total of 7 minus on that side. Have I made any mistakes? Doesn't look like it. Looks like I need to add a weird number of electrons. Sorry, that's 7 plus. So I need to get it to 2 plus, so 5 electrons. So got to times these things by 5 to get these to be equal. Can cross out the electrons. And there I go. I've got 4, 5, 5, and 8. That's as fast as I can do it. So I'll just put those numbers in there. So there's 4, there's 8 hydrogens, the Fe on this, and there's 5 on both sides. That's kind of crazy. All right, what does the mark scheme say? Correctly balances 8 and 4 in the equation, and then 5 and 5. So bizarre. No working for that. That's bizarre. Okay, anyway, so we got it right by doing the proper method and the proper working, which is over here. Whatever. Okay, calculate the percentage iron in the ore sample. So you're working. Ouch. Nice that they give no scaffolding. So I think they've made a nice hard question for this one. I like this one then, because the test has been pretty easy. The only thing is this should be routine for you. So you should have done so many of these titration questions before. It should be pretty easy. So we start from this one here. So the potassium, how many moles of potassium permanganate did we use? So number of moles, okay, NO4. C equals N on V. A lot of people are screwing that up. I always write it out again. So the concentration is 0.05. They're all to 4 sig figs, so I'm just not going to rewrite the zeros out. And that will sort of, I'll just have to remember that there are significant zeros on the end of these things. So hopefully I don't make any calculation errors as well. So that's how many moles of potassium permanganate we used. So 1 mole of permanganate is was neutralizing 5 moles of this, Fe2 plus. So 8.2 by 10 to the minus 4 is to x. So x equals 5 times 8.2 by 10 to the minus 4, which is nice. It's still on my calculator. So 0.041 moles of Fe2 plus. All right, so no doubt when I get to, I don't know if I want to look at the mark scheme. I don't like their working out. For my students, no excuses. It's got to be exactly looking like this. All right, it's clear or the same all the time and logical. All right, so I've got this many moles in, what did we get? That was in a 25 mils. All right, so therefore the concentration of Fe2 plus, concentration is number of moles on volume, so it's 0.041 over 0.025. This is quite nice since I can just keep rolling on the calculator and not get any round off errors. 164 molar. All right. So that is the concentration of the stuff, but you actually had a total of 500 mils. So if I just move down here, so in a total of 0.5 liters, the number of moles of Fe2 plus that was titrated to Fe3 plus is C times V is 0.164 times 0.5. And that gives us 0.82 moles of Fe2 plus. All right, we're almost there. So just going back here, so the percentage iron in the core sample. So that is, we just need the mass of that, and that'll tell us what it is. The mass of iron, what was the total mass? 8 grams, there we go. So 8 grams was the original ore. So we need that. Just remember that. So there was 8 grams ore. All right, so the mass of the iron that we want in the ore, so number of moles is mass on molar mass. So mass is number of moles times molar mass. So that's 0.82. If I just look at the periodic table, just 55.8. Now, I have to look at the proper one because it looks like we're doing 4 sig figs for everything. So I'll just check out periodic table. Yeah, sig figs wouldn't surprise me if it's 4, since that's what we're doing. Yeah, 55.85, so I have to just double check. Yeah, okay, so that's good. All right, so 0.82 times 55.85. Just keeping 4 sig figs. Even though it's 1 decimal place, it may end up being nasty and have 9s and 8s at the end, so it will actually count. Grams. So percent yield, percent iron is part divided by the whole. So we got 4.5797, and that was 8, and that's times 100. So divide that by 8, and that gives us 57.24 grams. So 1 decimal place, 57.2. Just look at the mark scheme. Correctly determines MnO4 is 8.2. Did that. determines Fe is 4.1 by 10 to the minus 2 did that. Determines number of moles Fe. Did the mass. Number of moles Fe. I did it a slightly different way. They jumped there and I went from there to there. So there's no reason why you'd lose a mark for that. I think I did a slightly... Yeah, I did it... They did it slightly different. I prefer to do it the way I did it. It's just a slightly different step there. They've gone straight from the mass dissolved and times it out somewhere else or something. I don't know. I don't actually care to know, to be honest. And then I just follow every single step logically, and the masking just jumps too much for me to care. So 4.5 and then part divided by whole 157.2. So that's all good. I think most markers will see that you get this correct, and then look for the key points. If you're missing one, you've done this bit slightly differently, they're not going to care. They'll still give you full marks. All right, so definitely an easier test. Like I do a content validity when I do my predicting the exams, but I don't really do a cognitive validity on how difficult they are. Just because they're doing the same content doesn't mean the questions are the same difficulty, and there is a huge difference between 2022 and 2021. It's also a lot of repetition. They've asked for half balancing twice now, and they almost never ask for it in the other tests from memory, if they have ever at all. Now they've asked for it twice. So there you go. I don't think I can predict now how difficult tests are, because this was a really easy one in my view, and 2022 was a really tricky one. So who knows what 2023 is going to be like. Just predict it's going to be... There's always this general trend of things being difficult, so I think things are going to get more and more difficult. My prediction is 2023 will be a hard one. So good luck.